Yes, Maha, am I audible to you?
Yes, ma'am.
All right. Maha, in the last class, we practiced some questions, but angular projection was still left, right? The completion of angular projection wasn't done. Like few questions we did. So, a few questions are there that I want to discuss with you. Some of them are old questions and some of them are new. First, you try it from your end. I'll discuss it. Okay. First, write this question, try it, and type me the answer.
Okay.
Yes, Maha. Tell me the steps. How did you solve this?
Just did tan theta equals y by x. Y will be the upper and x over here. And then 0, 0 will be 0. So, like,
Uh-huh.
origin is both zeros. So, we don't really need that, right? So, we can focus on b, which is root 3 and 3. So, x-axis, for the x-axis, it's root 3. And then for the y, it's 3. So, tan theta equals sine by cos, right? Sine will be y-axis, cos will be the x-axis. So, 3 by root 3 equals root 3. So, theta equals 60.
Okay. That is fine. Maha, just in case if you get a question, if you get some value like this, where the slope, this is not 0, comma 0, then will you still have the same answer or it will be different according to you?
It will be different, right?
It will be different. Like, see, in this question, 3 minus 0 was important because everything started from the origin. Okay, divided by, this is root
So,
3
3 minus
minus
0.
0. Yes, because this is at the origin, that's why your x and y coordinates are 0. So 0, comma 0. All right, but if some values are there, you'll have to subtract that. Okay. One more question is that, one more question, let me share. I hope this you'll not find it difficult, but this kind of question has been repeated a lot in the exams afterward. Like, this is a very old question, but the question has been repeated recently. And one more question from 25 I'll discuss with you. First, you attempt this one. Okay.
Ma'am, I'm not able to do this.
Okay, see, Maha, for the angles of projection, we know that horizontal ranges for the complementary angles. Do you know for that?
Yeah.
Then, see, if I add both the angles, if I have this is basically a very just a small trick because 90 degrees is directly not given to us. That's the problem with this question, right? For angles of projection of a projectile at angles 45 degree minus theta and 45 degree plus theta means here 45 degree plus whatever is the angle and 45 degree minus whatever is the angle. When I'll add both of these, what will it become? 90 degree
Yeah.
complementary, and the horizontal ranges for the complementary angles are same. R theta is equal to R 90 minus theta. So ratio will always stick to 1:1. Getting my point?
Okay.
Okay, so this was the catch in this question. Uh, Otherwise, it's a very easy question. But this kind of concept I've seen, Maha, this has been used a lot. Okay, in other questions also I've seen that this concept has been used a lot. Before, just copy down this and one or two theoretical things I have to discuss with you.
Then, ma'am.
Okay, Maha. See, few points that I wanted to discuss with you from this. When we are talking about ground to ground to ground projectile, this term you can see in some of the questions. That's why I just wanted to discuss this. Ground to ground projectile means that the body is starting from the ground and coming back. The typical projectile that we depict. So from here, let's say we start and it moves to here. Okay, this starts from here, this moves to here, like this. This is what the ground projection is. So a formula of trajectory we've already studied. So the formula of trajectory can be modified because some of the questions will be very helpful if you know these formula directly. So one of them is that for the trajectory equation of trajectory, see simply x tan theta minus g x square by 2u square, and you'll have sec square theta. Okay. Sec value usually we do not remember. Okay, we try to write it in the reciprocal form, 1 by cos and all. But for few values, you should remember it. The, at least the trigonometric table from 0 degree, 30 degree, 45 degree, 90 degree, and all. Okay. Second is y is equal to x tan theta minus g x square by 2u square 1 plus tan square theta. This one. Like if the tan value is given to you, these things you should know as secondary formula. Wherever you can substitute them. Then next is some questions are there that are based on the incline problems. Incline problems in projectile. Okay, this was ground to ground projection. But if I make this as inclined plane problem. So if it is inclined plane problems, it means, see, projectile, let's have thrown a ball from an inclined plane and it reaches the ground to here. Okay. So this is what is the inclined plane problem. Let's say this is the initial velocity u. This is making some angle theta. Okay. So this will be u cos theta. The perpendicular one will be u sine theta. Okay, so this is u making an angle of u cos theta. Basically, we have resolved all the components. Now see, not just this, you'll have to resolve the acceleration due to gravity also. The problem is here that see u cos theta, u sine theta, we already use. We have been using it, u cos theta, u sine theta. So when we resolve this, when we resolve the acceleration due to gravity, like if I have this as acceleration due to gravity, this also needs to be resolved because now your g is not just directly pointing towards the ground. You'll have to have things that are perpendicular to the plane and parallel to the plane. As we discussed in the laws of motion also, that everything has to be resolved perpendicular to the plane and parallel to the plane. So if I have acceleration due to gravity, let's say little downward, like this straight, okay, this is g. So when we'll, now I'll have to resolve them like this. Okay, so this value, whatever is the angle of the inclination, let's say this angle, because the theta I've already chosen for the angle of projection. So for the angle of inclination, I'll write alpha. Okay, so I'll just make this clear also here that theta is the angle of projection while alpha is the angle of inclination. Okay, so see, when we resolve this, this is g, let's say this angle is alpha. So this one, when we'll resolve, this will become g cos alpha, and the perpendicular one here, this will become g sine alpha. Okay, g cos alpha and g sine alpha. This is what should be there in your mind. Okay, this is a complete figure. Now, when we are talking about the different formula that we've already discussed earlier also. So the velocity, when I talk about the time period was in the normal angular projection. Two u sine theta by g. Okay. So this will be 2 u sine theta by
G
g.
square, right?
No. 2 u sine theta by g for time period. So this will be 2 u sine theta by g cos alpha. Okay, this will be the formula. Instead of g, you are going to put g cos alpha. This is one formula which can be helpful to you if it comes. Okay, and the two velocity, regarding the velocity. See, velocity will have its two components, x component, y component. As we discussed in projectile motion, we usually have these two components, right? So for the velocity along the x-axis, this will be u cos theta minus. Now g, here we'll have sine alpha t. Means we have no u cos theta minus gt. So instead of just putting gt, we have g sine alpha t. Okay, this is the formula for the x-axis. And for the y-axis, same formula, but the sine and cos will be interchanged. This will be u sine theta minus g cos alpha t. So these are the velocities. So finally, when you're going to calculate the net velocity, you will use this only under root vx square plus vy square. like this. This is what can be used. Okay, v under root vx square plus vy square.
Yeah.
So this is, got it, ma?
Yeah.
Okay, and for height also you should know the formula. See, height and range both. Height, I'll tell you. See, u square sine square theta here also. What's the formula? Completed for a normal angular projection
By 2G.
by 2g. Yes, u square sine square theta by 2g. Here it will be 2g cos alpha. Okay. U square sine square theta by 2g cos alpha. Then we have the range of motion, that is 2u square sine theta. This is an important one. Okay, range of motion is an important one. U square sine square. Now cos theta plus alpha. 2u square sine theta, 2u square sine theta cos theta plus alpha divided by g cos alpha. Okay.
Yeah.
These are some things that are completely new for you. And this is based on the problems on inclined. This is not difficult. It's just that few components we are taking. Like for the time period, we have taken g cos alpha. For x component sine alpha, y axis cos alpha, because you can see this is along the y axis, while this is along the x axis, like this. Okay. Then for height also, again, instead of g, we have taken g cos alpha. For the range of motion, it's slightly different because of identities. Fine.
Yeah.
Okay. Write it down, Maha.
Done. Done, ma'am. I'm done. Done, ma'am. Done.
All right. Now, a few more things are there. From motion, this inclined plane is not very, very, very important, but this is a topic that you should be knowing. Now, the concept of relative motion I'll be discussing with you. There's relative motion in 2D and 1D. So, 1D we have discussed a bit, but before that, few small things are there that I wanted to discuss with you, and one or two questions also. Projectile from a moving platform. Like, see, if I say an example that I give you, let's say there's a car and a person is standing on this car. Now, this person throws up a ball. Now, this covers up a projectile motion. And this car is already moving with some velocity. Let's say he throws this with amount, let's say with a speed of 10 meter per second. And the angle that is made with the horizontal is 53 degree. Actually, it's a question. This is a question directly, which I'm discussing in the form of an example. So that's why I'm putting such precise values. Otherwise, don't think, otherwise I would have put 30 degree or 20, 45 degrees. So 53 degree was there in the question from the horizontal with the car. Now, see, when we are talking, so this car is already moving with a certain velocity. Okay, car is also moving with a certain velocity, and the person is throwing up the ball with its initial velocity. Fine. Now, if you are asked to calculate anything in this situation, so the thing that you'll have to do first is apply the concept of relative velocity. Apply the whole concept of relative velocity. Like if let's say this is making an angle of 53 degree, this is 10 meter per second, this is the perpendicular, this one is the perpendicular part, this is the horizontal part. You resolve the vectors first. This will become 10 cos 53 degree. This one will become 10 sine 53 degree. So what do you have? You have now two values. Now see, if I say this is a boy, this is the car, what you'll have to do, you'll have to apply the relative concept of that the relative velocity of boy with respect to the car. That will be relative velocity of the boy minus the the absolute velocity of the boy minus the absolute velocity of the car. Or from here, what you do, if you have the relative velocity, okay, this much is there. If let's say I have some value which I want to find out to proceed further. So let's say VB vector will be equal to this VBC vector plus this VC, right? So from here, I'll be able to get the velocity of the boy, and that can be used even if I don't know what's this velocity of this ball.
Okay.
Okay, for the initial velocity, if I don't know what's this 10 meter per second and all, so you'll have to apply the relative velocities concept. That is with respect to A, with respect to B. This you have to do, perform resolution of vectors. These are the two things that you'll have to cover. Fine?
Yeah.
Okay, note this down.
Done now.
Maha, please note this question. This is the one which I was referring to, that yes, questions are there from this. First, you write this. Okay.
I'm gonna read now.
Question you have written, Maha?
Yeah.
Okay. See, here what we'll do, we'll assume that the velocities along the x and y axis are something. Okay. Vx or like that. Vx or Vy. We'll assume it to be like that. Fine. Velocity across the x-axis. Everything has to be resolved once when we are talking about the velocity. It also has to be resolved. Correct?
Yeah.
Now, see, apart from this, Maha, when we are talking about Vx, what exactly is Vx? Like displacement? Can I say this is displacement over time? If I say,
Vx
what?
is velocity of x axis.
Yeah, with respect to time, like, can I say Vx is equal to dx over dt
Yeah.
and Vy is dy over dt? See, question says that two particles A and B are connected by a rigid rod AB. The rod slides along the perpendicular rails. Velocity of A to the right is 10 meter per second. What is the velocity of B with angle alpha is equal to 60 degree? So see, velocity along the x-axis is dx over dt. Velocity along the y-axis is dy over dt. From this figure, this is given as y, this is given as x. So if I calculate tan alpha, what will it be equal to?
Y by x.
Y by x, exactly. So from here, can I say y is equal to x tan alpha?
Um,
Cross multiply. If tan alpha is
oh,
y
okay.
divided. Okay. Now see, if I have, let's say the velocity is, this is y is equal to x tan alpha. Now, if I differentiate this with respect to time, if I take this equation and I differentiate it with respect to time. So I'll write it also, differentiate with respect to time. So will this not be equal to dy over dt? And from this side, dx over dt tan alpha. Tan alpha will not be obviously differentiated. X and y are the variables, they'll be differentiated. Now dy over dt and dx over dt, what did we discuss? This is vy is equal to vx tan alpha.
Okay, yeah.
Getting it? Now see, velocity was already given to us. Velocity of A to the right is 10 meter per second. What is meant by velocity to the right? Vx, right? Velocity to the right will be Vx. It means we are already provided with this Vx. This Vx, we are already provided with this, that is 10 meter per second. And alpha is also given in the question, that is 60 degree. So what do we have to calculate? What is the velocity of B when angle alpha is 60 degree? Velocity of B means C. It says both of them are perpendicular. Perpendicular to this will be Vy. It has not given anything directly. The question was very simple. Question meant that Vx is 10 meter per second, theta is 60 degree. Calculate Vy. Directly, if we had known this, we could have written tan theta is equal to Vy by Vx.
Yeah.
Right? You could have directly written it. Problem is that question gave a lot of detailing, and this is what is meant by when it said Vy. Vy will be equal to 10 tan 60 degree. Got it? So tan 60, I think right now we can get the answer also. Tan 60 degree is root 3. So 1.73, so 17.3 something, right? 17.3 meter per second something. Now we have to take the options for this. Okay, straight away. Answer we have D. Got it?
Yeah.
Maha, in the next class, I'll discuss relative velocity in 2 dimensions. Fine, that would be the last topic from this. And this question you can copy it in the next class. Right now, I have a class. I'll just start
Okay,
this.
thank you, ma'am.
Okay, all right, Maha. Thank you.